Welcome everybody to my presentation on automated ontology design pattern substitution. To begin, I'll give a brief overview of the structure of this presentation. I'll provide some background on foundational ontologies and design pattern alignments, followed by related work in the field, along with some examples drawn from the literature, and then I will specify the problem this project aims to solve and the approach taken thus far. In the field of ontology engineering, foundational ontologies, also called top-level ontologies, are used to specify high-level domain-independent concepts and relations with which to model a domain. Their use results in higher quality modeling and enable interoperability between ontologies within and between domains. The application of ontologies to real-world problems often involves verbalizing the knowledge represented within an ontology in natural language. Because of their abstract nature and the manner in which foundational ontology roles split elements semantically, using a foundational ontology tends to clutter this natural language output, obscuring the intended meaning. I'll provide an example of this in a related work section shortly. The ability to simplify ontologies which use a foundational ontology, changing the semantic representation to one which has the same meaning but a more intuitive representation, therefore, would be useful in closing this gap. Primary input to this project is work done on ontology design pattern alignments, such as that done by Professors KEET and FILLOTTRANI, in which they identified several pattern alignments. And that by Nicola Guarino focused on reification and truthmaking, which does not have pattern alignments specified, but series of patterns of increasing complexity for which alignments would need to be derived. Other areas I have investigated include ontology modularization and modular instruction, along with automatic ontology generation. And finally, the heterogeneous toolset, or HETS, is a set of tools for conversion and between logics built on the theory of institutions. Professors KEET and FILLOTTRANI have identified 6 ontology design pattern alignments in their work. The class versus object property alignment, where a role, also called an object property, roughly functioning like a verb in natural language, is reified into a class in order to make use of a foundational ontology role such as participation. The PERDURANT class versus object property alignment, which is a constrained version of the class versus object property alignment, in which the role is reified into a PERDURANT. It is distinct from the class versus object property pattern in that in the latter the class representing the reified verb need not be subsumed into the PERDURANT class. The class versus data properties alignment, where information relevant to a class is stored in a role rather than a data property, as roles can be reasoned over. And a sub-pattern, the qualities versus data properties alignment, which is similar but uses the foundational ontology's quality class. The representing roles alignment, which exists because foundational ontologies use inherence rather than subsumption or subclassing, which violates the subsumption requirements of ontocline. And inherence here indicates that a property exists within something. The class role attribute pattern, which is a byproduct of syntax refactoring, which occurs in the process of introducing a foundational ontology where an additional role is introduced. And finally, the vocabulary alignment pattern, which specifies matching vocabulary between two ontologies. Here it can be interpreted as a renaming. Here is an example of the PERDURANT class versus object property pattern alignment drawn from the same paper. The role runs on the left is reified into the class running on the right and is a PERDURANT class. The foundational ontology roles participation and involvement are introduced to specify the relationship between runner, running, and marathon. Here is an example of a series of truth-making patterns of varying strength from Guarino's work. An alignment is not specified in his work, but the pattern series are useful as they tend to use labels which don't change part of speech, as in the previous example where runs became running. So instead, color remains color, and as such they provide a convenient stepping stone to the substitution of the other pattern alignments. On the right we have an approximation of the verbalizer output for each pattern instance, demonstrating how foundational ontology classes and roles can obscure verbalization, especially as the roles distance the concepts that we wish to connect. The examples provided in the related work section specified what would be instances of a particular pattern alignment. For verbalization, it would be useful to substitute the foundational ontology form for the simplified form. However, in the previous work, there's no algorithm for performing that substitution. The first research question for this project is, what is the frequency of occurrence of the identified patterns in selected real-world ontologies? And the second is, can the 6 design pattern alignments foundational ontology form be automatically substituted? My approach to the theory component is to model it as transformations based on pattern matching over an ontology. Key concerns include proving monotonicity, that no new deductions are possible after the transformation, and making sure that selected substitutions don't interfere with one another. The system contains 6 major components. First, if the input ontology is not in first-order logic, it is converted to first-order logic with heads. Then the ontology is passed, and all instances of the foundational ontology patterns are identified, and their corresponding simplified form is calculated. These are then presented as candidate substitutions to the user, who chooses which to apply. The chosen subset is then analyzed to ensure that the substitutions are compatible with one another, and if they are, the transformation is executed. Finally, heads is used again to ensure that no new deductions are possible. Thank you for your attention, and I hope you've enjoyed the presentation.